This is a pretty standard question you would get in a university statistics course if you were asked about if you were studying normal distribution. Back in the olden days, you would have to take, because it's normally distributed, we would have to use a standard normal distribution and convert our scores into z-scores. We don't have to do that anymore. The calculator is going to do all of that for us. At the university I teach at, you're expected to know how to do this on calculators, so that's what I'm going to do today. And I feel a sneeze. Excuse me. Okay, so in the U.S., the IQ scores are normally distributed with a mean of 98 and a standard deviation of 15. So I have a normal distribution, and the mean is 98, and the standard deviation is 15. What is the probability that a randomly chosen person will have an IQ score higher than 105? So 105 is somewhere to the right of 98. And so the answer is going to be this area off to the right. Once, of course, it's converted to a z-score and I get the area for a standard normal distribution, but that's going to be my probability. So the command I need in the calculator is the normal CDF command. And I need to have my left score, then my right score, then my mean and my standard deviation. Now in the calculator it'll ask for low and high, but you know, if you're reading it off of here, for this red area the left score is 105, so the lower limit is 105. And then the right score, well, there's no right limit. This keeps going on in theory forever. There's no infinity button on your calculator, so the way you handle that is you type in a really large number. And then for our mean, we were told it was 98 and our standard deviation is 15. So now I'm going to show you how to do that on the 84 plus. So I'm going to do second vars, and I'm going to come down here to normal CDF. That's where I find it. So now my lower limit, or my left score, IQ score here, is 105. Notice that the default is for a standard normal distribution. We're just going to rewrite over everything. And then my right limit, or my upper limit, technically is infinity, but we don't have an infinity button, so I'm just going to give a really large number, 10 to the 99th. Then here my mean is 98 and my standard deviation is 15. Then I'm going to press enter again. And notice here it's how I would have shown it typed there. Then I'm going to press enter. And so that red area is what our probability is going to be. And we take that to 4 places typically. So the probability that if you took a random person on the street and gave them an IQ test that they would score higher than 105 is 0.3204. So if you think of probability as a number between 0 and 1, that's how you would write it. If you think of a percentage, you'd multiply it by 100. So I do have the answers down there because we want to know that our answers are correct. Okay, so that's the first one. What is the 85th percentile? Okay, so again, I have a normal distribution. And the 85th percentile is the IQ score that separates the bottom 85% of scores from the top, 100 minus 85, which is 15%. So 85 percentile is quite good. Only 15% of the country got better than you did on an IQ score. All right, so if this is where our mean score is, 98, then your 85th percentile is going to be more than half the area under this curve. So it's going to be about here. And if you think of the standard normal distribution where the total area under this curve is 1, then the 85th percentile, you want this IQ score here that has as its left area 0.85. So that's what I need to find. So I need the IQ score with left area. So the IQ score X with left area 0.85. And there is a command that will give me that. So I call it inverse norm. Now on the 84 plus, the default is the left area. So you have to tell it left area, then the mean and the standard deviation. So 0.85 and 98 and 15. And then this will give us the IQ score for the 85th percentile. So I'm going to show you guys how to do that now. Do second vars. And we want to come down here to inverse norm. So when it says area, the default is the left area. Now notice that we have the left area here, but I'm just saying it's always, you're always going to have to give it the left area. So if you had right area, you'd have to do 1 minus. But here we have the left area, so we're good. And my mean is 98, and my standard deviation is 15. And then you can see now it types up the way I hand wrote it there. So if I take this IQ score to 2 decimal places, then an IQ score of 113.55 would be considered a score that's the 85th percentile. Okay, and so that does check with our answer there. Okay. What percentile is a score of 65? Okay, so now well, where is 65? It's to the left of 98, so it's somewhere over here. So that's an X value. And what percentile is? Well, I need to get this left area. So the percentile will be the left area, and then you have to multiply it by 100. Okay. All right, so to get this left area, once again, I'm going to need the normal CDF command. I'll need to provide it with a left score, a left limit score, a right limit score, and the mean and the standard deviation. Okay, once again, there is no left limit here because that's going off to negative infinity. There is no negative infinity. Whoops, there is no negative infinity button on your calculator or an infinity button. So you give it a really large negative number. So minus 10 to the 99th. And then my right limit is going to be 65 because I want to get this red area. Then 98 and 15. That will give me the red area. And then I'm going to take that answer and multiply it by 100 to get the percentile. Okay. So I'm going to do second vars, and I'm going to come down here to normal CDF. So my lower limit or my left limit, and it's already got that standardized. That's the default in there, so I'm just going to leave it there. The upper one, the rightmost one, is 65. And then my mean is 98, and my standard deviation is 15. And then I'm going to press enter and then enter again. And then I'm going to take that number and multiply it by 100. And that will give me my percentile. So if you score a 65 on an IQ test, then you are in the 1.39th percentile. So an IQ score of 65 means that 1.39% of everybody in the U.S. got worse than you did. And then 100 minus 1.39%. 98.61% of people in the United States did better than you. So an IQ score of 65 is not a thing to brag about. Okay. All right, so let's take it to the last one. What is the probability that a group of 16 people will have an IQ score greater than 105? So how is it different from this one? Well, we have a group of people, and so we are going to use the central limit theorem. We have a normal distribution here, and so we're going to replace our standard deviation of 15 with a group standard deviation. And so that's going to be our individual standard deviation divided by the square root of the group size. So 15 divided by square root of 16 is 15/4. So the answer will be normal CDF, and my lower limit or my left score is 105. Then there will be no highest limit. My mean is still 98, but now my group standard deviation is 15/4. And then that will give me my probability. So again, second vars, normal CDF. So my leftmost score is 105. My rightmost score would be infinity. I don't have infinity buttons, so I use that. And I have 98 for my mean, and this time my group standard deviation, so it's a standard deviation that has to be replaced with a group standard deviation, is going to be that. And then I press enter again, and so the probability that 16 people, so a group of 16 people, would have a mean IQ score. So a mean IQ score greater than 105 is 0.0310 if I take that to 4 places. It's not very high, is it? And as a percentage, you would take that and multiply it by 100, and that would give your answer as a percentage. Okay, so I hope that that helps you understand the type of questions. I hope it also helps understand with the different types of questions that you could be asked for this. Okay, thanks for watching.